everyone. My name is Krishnan Nair. I am a student of a Master of Science in Data Science program of Liverpool John Moores University, and today I am presenting my thesis on predicting product backorder in supply chain using machine learning algorithms on class imbalanced data. The very first question when I hear this particular topic is like, what exactly is the back order? So, back order is a phenomena where the order cannot be fulfilled due to lack of supply, or the product is out of stock. So, the manufacturer is not able to deliver that particular product to the customer, but the manufacturer guarantees that in a later that the manufacturer will be able to deliver that particular product to the customer. So the customer actually waits for that product to be delivered in future. So now once I hear to this definition of backorder, the very first question comes to my mind is like, how it is different from the situation of out of stock. So the co- very best example or very basic differentiation between the back order and the stock situation is like, there is no guarantee from the manufacturer or the supplier and that the product would be delivered in case of out of stock. So even if the customer anticipates that the product will be delivered, there is no guarantee from the manufacturer or supplier, so he or she would have to wait, say we for indefinite period of time. However, in case of back order, manufacturer or the supplier guarantees a particular date, and within that date the manufacturer commits that I will deliver that product to the customer. So that's the basic difference of the situation of back order and out of stock. Now coming to the reason, very common reason of back order, and few of the most important reason are erroneous forecast. So if the forecasting mechanism within the organization is poorly managed, and the department is not able to gauge the forecast of the products, it there is a high chance that the product will culminate into a back order scenario. So the forecasting of the organization is forecasting mechanism of the organization is of prime importance. So there is due weightage for that mechanism, else the product there is high chance that the product might go into the situation of back order. Second reason is demand exceeding forecast. So this might be the case, like there is a sudden demand in the spike in the demand of the product, and due to that the customers are buying it more, or more customers are buying the product. So due to that reason the products are getting into the situation of back order. So very common example or very latest example for this particular reason is that of the hygiene product back orders, which we witnessed during the COVID pandemic. So people were buying the hygiene products like hand wash, sanitizer in high volume. Due to that the product went to back order, but the manufacturer of those hygiene products committed that, yeah, we would be increasing the supply of those products, we would be increasing the production of those products to maintain the stock level in the shelf. That's the second reason. Third reason is the supplier issues. So supplier issues might be, there might be the logistical or transportation issue, there might be excessive lead times, there might be legal issues, there might be uh, say administrative issues at the supplier. So if the supplier delays the delivery of the product, there is a high chance of back order, the product won't be available for the customer. Now the fourth reason is poor warehouse management. Warehouse management is also critical reason for the back order. fifth reason is the delayed order. So if you are placing the order to the manufacturer and it comes in, obviously it will come in a delayed fashion. So so when the customer actually visits the store to buy the product, it might be the case that there would be a back order. Now, after viewing the reasons for back order, let's see what are the business impacts of back order. One of the major business impact is loss of sales and revenue. So it's a direct impact on the sales and revenue. So the customer expects the product to be on the shelf, customer visits the store, and at that moment he or she doesn't see the product, so he is actually delaying his decision to buy that product. So that's a hit on the sales and also in the revenue. So once a customer decides he wants to buy a product, but at that moment he is not able to get that product, so that makes the customer dissatisfied and he is not happy that he wants a product that, but the manufacturer or supplier is not able to deliver. So that might lead to the customer dissatisfaction. And there might be a case that customer might look for alternatives, or might be the competitors product, and this might lead to the customer churn. Now, if a product goes to back order, there might be a case that to uh, replenish the shelf, the supplier might have to spend extra, might be in the logistic, might be some other ways to replenish the stock on the shelf, so that might lead to increased cost. Last business impact is the loss of market share. So if if there is a scenario of back order, so by default there is a chance that the customer might go out in the market looking out for more and more alternatives. So that is directly affecting the market share of the organization, because the customer is now looking for alternatives. You lost the goodwill of the customer, so that would shrink the market share. So the occurrence of back order is actually unavoidable. It's unavoidable. However, by using some modern day machine learning algorithms and the computational power we have at our pedestal, now we are in a position that we can predict the back orders in some of the products. So what we need is the historic data of the sales, the forecast, uh, the quantity on hand, the stock level at the shelf, the any other criteria which is directly or indirectly related to the products attributes. So what we in the modern day, how the data is managed is to generally it is managed through ERPs, enterprise resource planning. So within ERP we have a very structured manner, the data is stored and managed, so this data can be used in a valuable manner to build predictive models to recognize the backorder situation of the products, and this will help to take business critical decisions whether to replenish the stock now or maybe on a later date. So if the scenario arises that I'm predicting that a particular stock keeping unit will go in back order, so the I can inform my manager that this might occur, so my manager can take the decision of replenishing the stock. So thereby I am preventing the situation of back order. So that's the benefit of the prediction modeling and the machine learning algorithms we are using. Now, coming to the aim and objective, what exactly we are doing in this thesis. So the main aim is to develop a backorder prediction classifier model using machine learning algorithms, and the goal is to study, predict the product back order phenomena and streamline the supply chain of the business. So obviously when I am preventing. So back order is like an obstacle to the supply chain. I'm preventing that obstacle by using some predictive models. So I'm streamlining the supply chain of the business. So that's how the predictive model works. Now, coming back to the objectives, to analyze the relation between parameters like historic sales, lead time, and forecast, and current inventory on the back order. So we have the target variable as whether the product goes to back order or not, and we have other categorical and numerical variables like the historic sales, lead time, and forecast, which will help us recognizing the target variable whether the product goes into backorder or not. Meanwhile, we also need to recognize whether there is any relation between these parameters. So that's our first objective. Second objective, to suggest a suitable balancing technique that can be applied on the imbalanced data set. So the data set which I'm using for this particular thesis is highly imbalanced. So the among close to 1.9 lakh rows, I could hardly find close to 8,000 to 9,000 cases where the product actually went to back order. So if I feed this data to my predictive model to build my predictive models, there is a high chance that the model will not be able to learn, will not be able to generalize the pattern in the data. So that's why it is of a very high importance that I uh, do the treat the class imbalance in a right manner, and so that I get the best benefit from that predictive model. Now coming to the third objective. So I am using more than one machine learning algorithm, and after that I will be evaluating the performance of each machine learning model. Following that, I will be comparing the evaluation metrics of each machine learning model. So this way I would be able to recognize which is the best machine learning model to predict the back order, given the situation I have the data, historic data of sales, lead time, forecast, etc. of the organization. Now, checking the literature review of how far this has been used until now. So there has been a backorder predictive model using machine learning in 2018, where it actually started. They use the machine learning algorithms to predict the backorder. Following that, in 2020, the researchers uh, did develop some empirical formula. They associated a profit function to the backorder prediction model, and through that and using the big data analytics, they did the backorder production prediction. Following that, in 2021, the researchers tried to manage the risk. By risk, I mean risk associated to the inventory management by backorder production prediction. So backorder is obviously a risk to the organization, because if my flow backorder is, just like I said, it's a flow obstacle to the flow of the supply chain. So if my supply chain is getting stopped, it is a risk to the supply chain. So they try to mitigate that risk by predicting back order prediction. And following in that, in 2022, a sustainable production scheduling was developed using backorder prediction. So they associated the production scheduling, like how the production should be scheduled, and they associated it with the backorder prediction. So this is the methodology we have used in the thesis. I gathered the raw data, I cleaned the data, I did feature engineering, I did model development, I did feature selection, I did feature construction in a loop manner so that I get the best result. Following that, I did the parameter optimization. Following it, I did the model validation with the test data. Following that, I came on to this result that XG Boost has the best accuracy, which is 98.77, and it is followed by Random Forest, which is 97.43. Naive Bayes and Logistic Regression were not that good enough in comparison to XGBoost and Random Forest. Gradient Boost and ADA Boost algorithms had moderate performing benefits, but the only downside which we had of XGBoost and Random Forest is that it is computationally expensive and we need good resources. Good resources, by that I mean good computers with high processing in power to develop, to build models using the dataset. XGBoost and Random Forest emerged as the most robust model, as we saw in the previous slide, that they were able to predict the backorder scenario with a accuracy of 95-97 percentage, offering it as the best practical applications. This model enables proactive decision making, effective resource allocation, and long term planning, ultimately enhancing customer satisfaction and optimizing supply chain operations. So, coming to the conclusion, uh, we found that so I did my model development by naive bias, by XGBoost, by AdaBoost, random forest, decision tree, logistic regression, and mm, yeah, all these machine learning classification algorithms. And among those, I found that XGBoost and uh, random forest gave the best benefit, like we saw in the previous slide. And now we arrive to the conclusion that in a practical scenario, XGBoost is the best classification algorithm for backorder prediction. So now, coming to these future recommendations, like what could be the future scope of this research. One is incorporating the external factors like market demand, supplier performance, economic conditions, and seasonal fluctuations. Like in the start of the presentation, like I said, there might be some unusual market scenario, like during the case of COVID, supplier performance. We could get it from the pattern, how the supplier is delivering the product, how far is the lead time, how less is the lead time, the pattern of the lead time, economic conditions prevalent in the current scenario, and the seasonal fluctuation, whether the delivery of the product is affected by any seasonal conditions. Different industries and different sectors have unique characteristics and challenges in managing the inventory and predicting back orders. The third future scope I would suggest is the research on products with shelf life, wherein the prediction of back order is of very high importance. So shelf life is the expiration of the product. So let's say products has expiration of 20 days. So if we overstock the product, then the product will lose its value. It's a economic loss to the organization. And if we are not stocking it enough, there is the case of back order. So in the case of products with shelf life, it is very it is of very high importance to uh, predict the back orders with very high accuracy. Thank you so much.